What's something people don't know about breathing underwater? We, as land-dwelling creatures, take breathing air for granted. But what about the fish that inhabit our planet's vast waters? How do they extract oxygen from a liquid environment? The answer lies in a remarkable organ, the gills. Fish gills are marvels of evolutionary engineering, allowing them to thrive in underwater worlds. These organs are the primary sites for gas exchange, enabling fish to extract vital oxygen from water and expel carbon dioxide. Join us as we delve into the fascinating science of fish respiration. In the depths of our oceans, lakes and rivers, a hidden world teems with life. Fish, in all their diversity, have adapted to these watery realms, developing unique ways to breathe and survive. Their gills, often hidden beneath a protective flap, are the key to their underwater success. Located on either side of a fish's head, gills are specifically designed for aquatic respiration. These organs might seem simple at first glance, but they possess an intricate structure that is crucial for efficient oxygen uptake. The gills are composed of several key components that work together seamlessly. The journey begins with the gill arches, bony structures that provide support for the rest of the gill. Attached to these arches are numerous gill filaments, which resemble thin, delicate fringes. These filaments are the workhorses of gas exchange, providing a large surface area for interaction with the surrounding water. The gill filaments are not just simple strands, they are further divided into even smaller structures called lamellae. These lamellae, arranged in rows along the filaments, appear as thin plates or discs. The lamellae are the true heroes of the story, as this is where the magic of gas exchange happens. These microscopic structures are incredibly thin, which facilitates the diffusion of gases between the fish's blood and the surrounding water. The large surface area created by the lamellae ensures maximum contact with the water, maximizing the efficiency of oxygen absorption and carbon dioxide removal. The efficiency of fish gills is further amplified by a brilliant mechanism known as the countercurrent exchange system. This system optimizes oxygen uptake by ensuring that the blood in the lamellae always encounters water with a higher oxygen concentration. Imagine two streams flowing in opposite directions, one carrying blood and the other carrying water. This is the essence of the countercurrent exchange. As water flows over the gills in one direction, blood within the lamella flows in the opposite direction. This counterflow maintains a constant concentration gradient, meaning that the blood is always exposed to water with a higher oxygen content. This clever system allows fish to extract a remarkable amount of oxygen from the water, even when oxygen levels are relatively low. Section 5. Water flow, the key to gill function. For the gills to function effectively, a constant flow of water over their surfaces is crucial. Fish have evolved different mechanisms to achieve this, depending on their species and environment. Some fish, like sharks, rely on ram ventilation. Ram ventilation involves swimming with their mouths open, forcing water over their gills as they move. Other fish employ a more common method called buccal pumping. This two-part process involves both the mouth and a bony flap called the operculum. First, the fish opens its mouth, expanding its buccal cavity and drawing water in. Then the mouth closes and the operculum opens, creating a pressure gradient that forces the water over the gills and out through the opercular openings. Section 6. Oxygen in water versus air, a crucial difference. It's important to remember that water and air hold vastly different amounts of dissolved oxygen. Air is about 21% oxygen, while water contains significantly less, typically around 1% or less. This difference poses a challenge for fish, as they need to extract enough oxygen from a medium that is naturally oxygen poor. To overcome this challenge, fish have evolved highly efficient respiratory systems, with their gills and the countercurrent exchange mechanism playing key roles. Despite the lower oxygen content in water, these adaptations enable fish to thrive in their aquatic environments. Section 7. Adapting to low oxygen fish survival tactics. While fish have adapted to breathe underwater, they still face challenges when oxygen levels drop. Factors like warm temperatures, pollution, and algal blooms can deplete oxygen in water, creating stressful conditions for fish. However, fish have developed a range of remarkable adaptations to cope with these low oxygen situations. Some fish, like bettas and catfish, have evolved labyrinth organs which act as supplementary breathing devices. These organs allow them to gulp air from the surface and extract oxygen directly from the atmosphere. Other fish, like some species of sharks, have the ability to enter a state of torpor when oxygen levels are extremely low. This slows down their metabolic rate, reducing their need for oxygen and allowing them to survive until conditions improve. Section 8. Beyond gills, other ways fish breathe. While gills are the primary respiratory organ for most fish, some species have developed alternative or supplementary breathing methods. One such method is cutaneous respiration, where gas exchange occurs directly through the skin. This is particularly common in fish with thin, permeable skin, such as eels and some amphibians. These fish can absorb a significant amount of oxygen directly from the water, supplementing their gill function. Another fascinating adaptation is seen in lungfish. As their name suggests, these ancient fish possess lungs, allowing them to breathe air directly. This remarkable adaptation allows them to survive in habitats that periodically dry up, burrowing into the mud and entering a state of estivation until the water returns. Section 9. Conclusion. The wonders of aquatic respiration. The world beneath the waves is a testament to the power of adaptation and the diversity of life on Earth. Fish, with their remarkable gills and other respiratory adaptations, have conquered the challenges of breathing underwater, showcasing the incredible ingenuity of evolution. From the intricate structure of gill filaments to the genius of the countercurrent exchange system, fish respiration is a marvel of biological engineering. As we continue to explore our planet's waters, we can only marvel at the wonders of aquatic life and the delicate balance that sustains these underwater ecosystems.